Hello, everybody. Today we are talking about hydrogen fuel. Okay, so we're going to continue our talk with renewable fuels. Today we're going to talk all about hydrogen fuel. So we're starting off right here and let's get started. So I've posted this video on the staff teacher webpage. So hopefully you guys will be able to view this. And it'll be a nice little introduction to hydrogen fuel. It goes into a little bit about what's produced, the mechanics that are involved, maybe where you can gas up with hydrogen fuel, where the hydrogen comes from or is derived from as well. All right, so moving on, hydrogen fuel cell vehicles. So the fuel cell vehicles, that is the main power source. Fuel-efficient vehicles powered by a fuel cell that runs on hydrogen gas. Those are always being developed. We're trying to use that as the most efficient means possible. How hydrogen gas is derived, hydrogen gas is derived from a reaction with water. So basically, we take the water and we break it down into hydrogen gas and oxygen gas. This is called electrolysis. It emits no air pollution or CO2 if the hydrogen is produced from a renewable energy source, meaning the energy that you're using to break the H2O down, the water down into hydrogen and oxygen, if that energy is derived from wind energy, from water energy, from geothermal energy, solar energy, then there is no net CO2 production because you're using energy, renewable energy, to derive more renewable energy. On the other hand, if you were to take coal, coal, natural gas, or petroleum to produce that hydrogen gas, well, there are going to be CO2 emissions because you're using a non-renewable form of energy. Currently, this technology is extremely expensive. That doesn't mean it's not out there. It just means it is very, very expensive. So this is a general type of looking hydrogen fuel cell. You could see right here in the middle, those are the hydrogen tanks. Notice there is a front and rear crash zone. Take a second. Why do you think the hydrogen tanks are placed in the middle of the car? Got it? All right. You're correct. Hydrogen is very explosive. Okay, so if this vehicle were to be in a collision, you want to try and minimize the amount of impact that those tanks would take. Doing so, we put them in the middle of the car, away from the impact zones of the front and the rear. We try and protect them as much as possible. Notice we also have side-mounted radiators. The air moves over those, and that cools the tires, the brake pads, other components of the vehicle. Electric wheel motors provide four-wheel drive, built-in brakes. Notice the inside of the car is very futuristic looking. Excuse me. Body attachments, mechanical locks that secure the body to the chassis. It is a similar car to what you're used to seeing. The difference is it runs on hydrogen fuel. Moving on to our next slide, we'll talk about how we convert that hydrogen, how we convert to a hydrogen economy. Now, Iceland plans to run its economy mostly on hydrogen, produced via hydropower, geothermal, and wind energy. So right there's a perfect example of how we are creating hydrogen using renewable forms of energy, okay? However, doing this in a larger, more industrialized country is difficult. The key term there being industrialized. When you rely on more of industry in your country, they rely heavily on fossil fuels. It's very hard to kind of pull away from that now, okay? You must convert economy to energy farming, solar and wind farms, from energy hunter and gatherer seeking new fuels. Essentially, this is just like agriculture coming about, okay? We went from a hunter-gatherer society to now a farming society, an agricultural-based society. How does that apply to fossil fuels? Well, we're mining, digging, gathering those fossil fuels to burn them. We're searching for them, hunter-gatherer, to now having wind farms, solar farms stay in one area, essentially like an like a plantation, almost a monoculture in a sense, and you're gathering that wind there, you're gathering that solar energy there. There's no infrastructure for hydrogen fueling stations. 12,000 needed at $1 million a piece. These are not cheap gas stations, okay? $1 million a piece. You're looking at $12,000 just in, $12 million, 12,000 million just in the infrastructure alone. Also, not to mention the high cost of fuel cells. Moving on, we are looking at hydrogen fuel cells, the process that's used to derive the hydrogen. We need to work backwards, take water, and from there we can derive oxygen and hydrogen. This oxygen should have a 2 right there. It's a diatomic element. The fuel cell is the device that operates like a common battery, where electricity is generated by a reaction between 2 chemicals. It requires hydrogen as a fuel, and that's obtained from methane. Or we can obtain it from water by electrolysis, applying electric current to water to split the hydrogen and the oxygen. So think about this. We are using methane, in some cases, CH4, right? 1 carbon, 4 hydrogens, to produce hydrogen fuel, or we are using water as a form through electrolysis, breaking that H2O molecule apart into hydrogen and oxygen. Continuing on, is this a viable alternative? Is hydrogen fuel worth it? Well, as with everything in this class, we have to think of the disadvantages and the advantages. So, disadvantages, how do we obtain hydrogen without expending more energy to obtain it than we would to harvest it or to break it apart? And we talked about this when we talked about nuclear energy right before we left. We said nuclear energy is a fission type of process. It's not a fusion. We don't have the energy. We don't have the technology for fusion. We break the uranium-235 down. We don't build isotopes up. We break them down. Same thing here, all right? We need to make sure that the energy that we put in is worth it. It's doing a good job. Also, what about the distribution center? What about those 12,000 gas stations at $1 million a piece? What about the hydrogen tanks in the vehicles and if there were to be an accident? Okay, it's be quite explosive. On the flip side, advantages. It's an electric motor. There are no emissions. It's 3 times as efficient as a combustion engine. And we talked about combustion engines before and how wasteful they are with regard to heat loss. It's pollution free. And there's an abundant amount of hydrogen, whether it is taken up in water or methane, CH4. So it is there for the taking. We just need to essentially harvest it. Moving on, we see again the inner workings of a hydrogen vehicle. Here's your hydrogen fuel cell. In this vehicle, the hydrogen tanks are located in the back. So how exactly does this work? Well, hydrogen is passed over a reactive layer, a membrane, and then there's another reactive layer. The hydrogen is used. Think about this as your catalytic converter or your gas pipe, your exhaust tailpipe. Oxygen passes on one side, hydrogen passes on the other. As the hydrogen moves through, electrons are stripped off the hydrogen. The protons pass through the membrane that is a proton-based membrane. Flow of electrons to move from one side to the other because they cannot pass through this semi-permeable membrane creates electricity. That is the flow of electrons. They meet up on the other side with the oxygen to form water, and that is your exhaust. Literally, you get water out of the exhaust pipe. Think of that oxygen as a magnet. It wants to pull those electrons around so that they join back up again with the protons, positive and negative charge, to combine with the oxygen. That is how a fuel cell works. Moving on, and this is our last slide for the day. Again, the advantages and disadvantages of hydrogen power. It can be produced from a plentiful amount of water, low environmental impact, easier to store than electricity. It's non-toxic. The hydrogen fuel cells are very efficient. It's an excellent substitute for oil. It's liquid, right? Our our original product, water, is a liquid. Disadvantages, though, it's not found in nature. Hydrogen gas is not found in nature. Methane and water are, but the raw material of hydrogen gas is not. CO2 emissions if produced from carbon-containing compounds, meaning your methane, if the hydrogen gas is produced through the use of non-renewable energy sources like coal, natural gas, or petroleum. It's a short driving range for fuel cell cars. They don't have a lot of mileage. Those hydrogen tanks can't give them 100+ miles. No fuel distribution system in place. There are no gas tanks. Energy is needed to produce the fuel. We need to put energy in. Now, whether we're getting it from a renewable source or a non-renewable source, that would make it either better or worse, but we need to put energy in order to obtain that fuel. So hopefully this has helped you to understand the effects of hydrogen fuel, the non-renewable source, and hopefully this has answered some questions for you. So hope you guys have a great day. Take care. Mr. F is done with this one. Bye, guys.